Hi everybody, welcome to Unit 2 Video 3. Please make sure you have out your Unit 2 notes packet. If you don't have it, please get that now. You're also going to want to use a straight edge and a pencil and then a colored pencil or something in a different color. All right, so let's go ahead and take a look here. It says, I can graph an inequality, identify and name 3 solutions, and verify the solutions. All right, so first what we need to do is graph the inequality. Right now, this inequality is in standard form. I need to put it into slope-intercept form. So the first thing I'm going to do is I'm going to subtract the 14x from both sides. So once I subtract the 14x, I'm left with 7y is greater than negative 14x plus 7. Then I'm going to divide everything by 7. And I'm going to get y is greater than negative 2x plus 1. So now that I have y is greater than negative 2x plus 1, I can go ahead and graph this. So let me move my graph down a little bit. So I'm going to start at 1 on the y-axis. The slope is negative 2 over 1. So I'm going to go down 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1. Okay, I can also go the reverse, up 2 to the left 1. Up 2 to the left 1, up 2 to the left 1. All right, now this is an inequality. So with inequalities, remember, if it's greater than or less than, but not equal to, you're going to do a dashed line. If it's greater than or equal to, less than or equal to, you're going to do a solid line. So since this one is just greater than, we are going to do a dashed line. So I'm sorry, I'm not using a straight edge, but hopefully you are and your lines are straight. Okay, so now it's saying y is greater than. So remember, when it's greater than or greater than or equal to, you're going to shade above the line. All right, so now we need to verify it so that we make sure that we shaded in the proper area. So you're going to pick 3 solutions and you're going to plug them in. So the first one I'm going to pick is I'm going to try this point right here in the shaded area, 4, 2. So I'm going to check the coordinate 4, 2. So I'm going to plug in 2 for y to the equation. So 2 is greater than negative 2 times 4 plus 1. So then 2 is greater than negative 8 plus 1. And 2 is greater than negative 7, which is a true statement. So it verified it, it worked. The directions ask us to check 3 points. So I'm going to try another one. So let's try 2, 0. So I'm going to try this point right here, 2, 0. So I have 2, 0. So I'm going to plug that in. So y equals 0. So 0 is greater than negative 2 times 2 plus 1. So 0 is greater than negative 4 plus 1. So 0 is greater than negative 3. That is a true statement. So that one worked also. And the last one I'm going to try, let's try something on the y-axis here. So we'll try 0, 6. So when I plug that one in, I'm going to get 6 is greater than negative 2 times 0 plus 1. So I get 6 is greater than 1, and that is also true. So I verified my 3 solutions. So I know that I shaded in the proper area. All right, let's go ahead and take a look at this next problem here. So what we need to do with this one, is we need to get the equation into slope-intercept form. So we want to move it into slope-intercept form, so we need to subtract 3x from both sides. We're going to subtract 3x from both sides. And then we need to, we're going to get negative y is greater than or equal to negative 3x plus 4. All right, so we still need to get the y by itself. It can't have this negative in front of it. So we're going to divide everything by a negative 1. But you need to be careful because when you divide by a negative, you have to switch the inequality sign. So this says now turns into y is less than or equal to 3x minus 4. So that's our new equation. Y is less than or equal to 3x minus 4. Okay, so I want you to graph this line, shade it, and verify the 3 solutions. So please pause the video and finish the problem. Okay, so let's see how you did. So this one, since it was y is less than or equal to, it was a solid line, and less than is you shade below the line. And so I shaded everything below the line, and then I checked my 3 points that were within this shaded area, and they all verified. They were all correct. All right, so now let's go to the next section. And for the next section, here's where you might want to use 2 colors, because you're graphing 2 separate lines, and we're going to see where the shading overlaps. Where the shading overlaps, that's where the solutions are. And this one also says identify and name 3 solutions. So, all right, the first one here, I need to isolate the y. So I'm going to subtract 1 from both sides. So I get over here is y is less than negative 1/2 x minus 1. All right, so this one I'm going to graph in my green pen. So I'm going to start at, I'm going to scroll down a little bit here, negative 1. And my slope was a negative 1/2. So I'm going to go down 1 over 2. So down 1 over 2. Oops. So down 1 over 2, down 1 over 2, down 1 over 2. And I can also do the reverse, up 1 over 2, up 1 over 2. All right, and since it was, y was less than, it means it's a dashed line or a dotted line. So I'm going to draw my dashed line. All right. And then it was y is less than, so that means I'm going to shade everything below this line. So everything below this line would be shaded. Okay, so now I'm going to go ahead and do my other line here. So my next line, I'm going to add the 15x over. So add 15x. So I get 5y is less than 15x plus 25. I'm going to divide each side by 5 to get y by itself. So when I do that, I get y is less than 3x plus 5. Okay, so that's my second line. Y is less than 3x plus 5. So I'm going to go ahead and plot that line. So I'm at 5 on the, oops, that's not 5. I'm at 5 on the y-axis. And I'm going to go up 3 over 1. So up 3, 1, 2, 3 over 1. And I can also do the reverse, down 3 over 1. 1, 2, 3 over 1. 3 over 1. 1, 2, 3 over 1. Okay, and it's also a dashed line because it's just less than, it's not equal to. So I'm going to draw my dashed line. And less than means shade everything below the line. So here's below the line. So where the green and the black in this bottom area here is where the shading overlaps. So that's where I need to check my solutions. So I need to verify 3 solutions. So the first one I'm going to check is right here. So 0, negative 4. So I'm going to plug in 0, negative 4. And since you have 2 equations, you have to plug them into both equations. So the first one was y is less than negative 1/2 x minus 1. So I'm going to plug that in. So I'm going to get negative 4 is less than negative 1/2 times 0 minus 1. So then when I simplify, I get negative 4 is less than negative 1, which is true. So then I'm going to plug it into my second equation. So I'm going to get negative 4 is less than 3 times 0 plus 5. So I get negative 4 is less than 5, which is also a true statement. So that one worked. All right, now I need to pick 2 more and verify those. So let's try negative 2 and negative 10, which would be down here. So negative 2 and negative 10. So into the first equation, I need to plug it in. So I'm going to get negative 10 is less than negative 1/2 times 2, or sorry, times a negative 2 minus 1. So then I get negative 10 is less than 1 minus 1. So I get negative 10 is less than 0. And then I'm going to, so that was true. So then I'm going to check the second equation. So negative 10 is less than 3 times negative 2 plus 5. So I get negative 10 is less than negative 6 plus 5. So negative 10 is less than negative 1, which is true. All right, and so for my last one, I'm going to try, let's try 6 and negative 8. So that would be down here. All right, so 6 and negative 8. So 6 and negative 8. So I'm going to plug it in the first equation. So negative 8 is less than negative 1/2 times 6 minus 1. So I'm going to get negative 8 is less than negative 3 minus 1. So negative 8 is less than negative 4. And that's true. And then my second equation, negative 8 is less than 3 times 6 plus 5. So negative 8 is less than 18 plus 5. So negative 8 is less than 23, which is true. All right, so I verified that problem and the shaded area, that they were true statements. Okay, so I want you to go ahead and try this one. Remember, you're going to figure out where the shading overlaps, and then you're going to check 3 solutions. This y is greater than or equal to negative 3 is one of our special cases. So you have to decide, is it a horizontal or is it a vertical line? All right, so go ahead and pause the video and graph. Okay, so let's go ahead and see how you did. So y is greater than or equal to negative 3 is a horizontal line. And then, so I graphed it here, it's horizontal. It was greater than, so everything above, so I shaded everything above the line. Since it was greater than or equal to, it was a solid line. So for my next line, which I did in green, it was y is less than or equal to 2x minus 5. So it's also a solid line. So where their shading overlaps is in this right-hand corner. So then I picked 3 points, which I did in blue here, and then I verified all those 3 solutions, and they worked. So hopefully we got the same answer. You can pick any points that you want in that shaded area. Just show that they are solutions to your inequalities, to both of them. All right, thank you for watching the video.